Good afternoon, everyone. Good evening. Welcome to class again. So this is the 16th session so far. This is 16th class. Right? So we've been having classes for the past 8 weeks. Right. That is actually a lot. So we are moving forward and making a lot of progress. So yesterday we continued with logistic regression, one of the machine learning algorithms that I introduced, right? So we did linear regression before that, and then moved on to logistic regression. So today, I'm going to show us how we can implement logistic regression in Sklearn or scikit-learn, right? So if we have more time, I'll also show us how we can implement linear regression. If not, we're going to just have to do that next week. So today we're going to actually be coding, and I'm having practice session, right? So for those of us that usually follow the coding class, you should have your laptop set. Okay, I have actually not sent the material yet, so you just have to follow with what we are doing. So let me see if I can quickly upload that. All right, so I'll share my screen in a minute. Screen. All right, so please, can everyone see my screen and hear me clearly? Just give me a minute, please. I'm trying to upload the today's class material to the Google Classroom so you can download it and follow along. Okay. Oh, I've not even uploaded yesterday's material. Just you should have reminded me. I've actually been quite busy with some other things, so it's skipped my mind. So let me quickly post the materials for yesterday and today. Um, let's go. Select. right. So we're gonna post this. Um, okay, so you see the material for today's class now. Right, I've posted it on the group just in case you want to follow along. You can download it and yeah, just follow along. So for yesterday's class on logistic regression, I'm going to upload that as soon as I'm done with the class. Right, so let's just continue. So today we're going to be looking at machine learning with scikit-learn, right? And we'll specifically be looking at how we can build a logistic regression model, right? We're going to look at that because we don't really have um, much time. We have looked at both linear regression and logistic regression today. For the sake of time, we're just going to look at logistic regression, and hopefully next week we're going to look at logistic and linear regression, right? But the concepts, the pattern or the flow of the implementation is similar is similar when building a linear regression model. So the difference is just the kind of data you'll be using, right? And also the evaluation metrics and the algorithm as well. All right, so let's proceed without further ado. All right. Let's see. Okay. So today we're going to quickly look at this. We're going to recap on logistic regression. Then we're going to look at how we can train a binomial logistic regression model and also a multinomial logistic regression model, and then evaluate our model, right? So that is what we're going to be doing today. All right. So let's quickly recap on logistic regression that we did yesterday. So yesterday we looked at logistic regression, what it is, the logistic regression formula, we looked at sigma function, we looked at types of logistic regression, we looked at evaluation metrics in logistic regression. So as we always do, I'm just going to ask us questions and we interact in the chat. So what's just quick question, we're not going to spend much time, just to recap what we've done. So based on yesterday's lecture, I told us what the sigma function is and what it does. So can someone just highlight that in the group chat? What exactly does the sigma function do in logistic regression? What is the role of sigma function? Okay, seeing some responses. All right, Samuel, map predicted the probability, we call it precious. It's used to map the predicted values to probabilities. Patience used to map the predicted value into probabilities. Adebayo one map predicted value between 0 and 1. Map predicted probability of 0 and 1. Map predicted probability. Sigma function is a mathematical function used to map the predicted values. yeah, so we actually um all got it right. So that is the function of sigmoid function. It is used to map the predicted value, right? It's used to map the output of your model into probability within the range of 0 and 1, right? So that's what it does. That's the function of the segment function. And it's what makes logistic regression different from linear regression, all right? So also, yes, we looked at types of logistic regression. So can can I get the types of logistic regression? What are the different types of logistic regression? All right. Binomial or binary, multinomial, and ordinal, binomial, multiracial. Who said multiracial? Okay, I believe there should be an error. Um, a typographic error. Okay, binomial, multinomial, ordinal. All right, so we have actually got it. So those are the types of logistic regression, right? So, but I said we're going to be focusing on two of them. We're focusing on two of them, which are binomial and multinomial, right? So the ordinal is quite not so commonly used, all right? So we're going to be looking at these two out of the theory today. How much a question the audio is not good. Try to check your network. It might be a network issue. So you follow the class. You should be able to follow the class and not have any issue. All right, all right. So we also looked at evaluation metrics in logistic regression. Yeah. So like, can someone just highlight the at least three of the evaluation metrics we talked about yesterday's class? All right, all right, that's fine. So I think we're all up to speed on what we did yesterday's class. So we have assumptions of logistic regression, which we didn't really talk about. So it's part of it is not part of the material, all right? So the we mentioned some of the things yesterday that would be a criteria for choosing logistic regression, which is part of the assumption. And one of them is binary outcome variable or more than two variables. All right, so that's multinomial variable. So that is a very important assumption. before using a logistic regression. So the other ones are almost similar to linear regression, right? There should be an independence of observation, right? Um, no multicollinearity between the independent variables. You should have a large sample size, right? Logistic regression actually require you to have a large sample size. So the reason we didn't really talk about that is because it is not as specific as it's not as specific as linear regression, right? So the assumptions can the assumptions are just they are things that you would know once you start using logistic regression algorithm, right? So you don't have to start like looking into details on the error or residuals like you do in linear regression. So, but there are some assumptions as well, definitely. So you can probably look that up, right? So you check out the different assumptions, or I'll see if I update this material, right? And then resend it again, or resend it with the assumption so you can go through it as well. Yeah. So, but anything that we are not paying attention to or laying emphasis on, trust me, there are things that you might not have to worry yourself so much about because there are a lot of things to look at in data science and in machine learning. Right? It doesn't mean they are irrelevant. No, definitely when you have enough time, you should go over them. But for the sake of time, we focus our attention to those things that actually requires our attention and that are more relevant. All right. So that's what we are actually doing. 3 months, to be honest, is not. It's actually a short time to to go over every single thing in machine learning and Python. Right? But with the with this curriculum that we have, it would help you with the foundation and it will give you a very good starting point. Right? By the time you are done, you'll be confident in your ability to perform the tasks that we've done in class. Right? And these are the things that are mostly sought after, right? And you shouldn't relax after this program if you want to, if you actually want to take data science seriously. You should go further to refine your skills, go further to take more advanced courses, build more projects, try different things. You see a lot of other things that um, new things basically, right? There's no end to learning. So just keep your mind open. Keep your mind open to learning new things. So that was it for yesterday's class on linear logistic regression. So today we're going to be implementing that. We're going to be implementing logistic regression model. So before we do that, I'm going to introduce the new library to us. So we have, let me just quickly create this. All right, so we've looked at, let me just write out the libraries. So far, we looked at several libraries. We looked at NumPy, we looked for numerical computation on arrays, right? On arrays, or you can just say NumPy working with arrays. We looked at pandas. which is for data manipulation. I remember I told us the meaning of pandas. Can someone remind us? Just a quick one. What does pandas is an abbreviation of something. So what is that full? What is the full name of pandas? Pan, it means something, and then the remaining this thing on that thing. So this is just a side knowledge. It's not like necessary for you, right? Nobody would ask you that kind of question. So I think I mentioned it sometime back when we introduced pandas. Okay, I don't know if anyone but pandas is panel data. It's just something you can just write back for panel data. So the pan comes from panel, this pan here, and then that is this. So it's just cool fact, cool thing, cool fact you can just keep at the back of your head. Nobody will ask you anything that you or will require you to know it. To be done today, so hopefully you will be able to catch up with the two classes. So, but you actually need yesterday's class to at least need to understand and then also the bond is also for now we are looking at another side ability to use these libraries. You should know how to use NumPy. You should know how to use pandas. You should know how to use matplotlib. You should know how to use seaborn. You should know how to use scikit-learn. Although you may not necessarily know everything about each of these libraries, but you already have an idea on how to use them. So just for backend engineering, some people put Python on one, they know is a libraries for cybersecurity, right? So data scientists, these are what you put as specific libraries that you work with. So libraries are actually not to use SQL, not to use scikit-learn, right? So you need to kind of build yourself on these libraries, right? This is the foundation for you. You should be comfortable with most of these libraries by now. So today we're going to be looking at another new library, for machine learning for the remainder of this program. These are the things you need to know as a data scientist for a start, right? So if you know these things very well, you are very very good to go. Then if you probably want to advance to artificial intelligence, advanced machine learning, deep learning, and all of that, then you can now add, let's say, TensorFlow, or PyTorch, right? So these ones they are used for deep, for the libraries we will be touching. So I'll just remove this one. So now let's look at how we can work with scikit-learn. Okay. So what I'm going to do, I'm going to call my import. So we just say scikit-learn is the name, right? But when I put it, what you use is sklearn, right? So I can come here and say scikit-learn slash sklearn. So anyone will do. Any one of them will do. I'll be sending this material as well. So I want to just make it as clean as possible. And now you should know how to customize your Markdown based on all the things I've been doing during class. So if you import sklearn with Anaconda and everything that we've set up, you shouldn't have any problem. Alright, so sklearn is it comes with Anaconda, so you can import it like this. But this is not how you be using sklearn. We're going to look at how we use sklearn, but this is basically sklearn, and we're going to see the things that compose this library. So to check the different modules and the functions and the classes and everything, the attributes of this particular library, what are we going to use? What particular function are we going to use? We also follow and we import exactly. So we use dir blueprint, so it will give you very well. Come here and say sklearn. Alright. So now if you do that, this is what you're going to get. Remember I told you that you don't use sklearn like this. Alright, you don't use sklearn like this. You use, I'm going to show you how to use it. It's not the same way you use import pandas like that, or import numpy, or import cbom. So we've been doing all these ones, right? It's like this, just straightforward. We import them with their alias. But sklearn is not going to be like that. So as we move forward, we're going to see how to do that. So this is just sklearn. We don't really have anything here because we're not going to be working with it directly like this. There are some things that we import specifically. If you So you have to import everything specifically in Sklearn. All right, that is exactly how we work with Sklearn. You understand it better as we proceed. So let's quickly go to the material we have here. All right. So what we're going to do now, we're going to train a binary logistic regression model. Right? So if you're used to this class, you already understand what the binary logistic regression model is. Okay, so binary classification is a type of classification task that involves classifying the instances into one of two possible classes. All right, logistic regression is a commonly used algorithm for binary classification. It models the probability that a given input belongs to a particular class. So all these things are just saying, just a summary of what we explained yesterday. Now, Sklearn provides a user-friendly implementation of logistic regression. I told us yesterday that the hardest part in machine learning is not the code, it's not the coding aspect, it's not the implementation. The hardest part is understanding how it works and understanding what to use. You understand? I think I said yesterday, you shouldn't focus too much on the coding aspect that you forget what is happening or how it is working, because that's what's going to inform your choice, right, of whatever function or whatever class or whatever thing it is you're going to be using in code. So if you don't understand the foundation or the backbone, it would be difficult implementing it in Sklearn. But once you understand exactly what you want to do, you understand what logistic regression is, you understand what linear regression is, you understand what machine learning is, you understand what independent variables are, dependent variables, classes, evaluation metrics, mean average error, R squared, you understand confusion matrix, you understand all these things, the implementation will be smooth for you. You won't have headache. All right. So that is what I want you to focus on. So today it's going to be straightforward. It's not like it's going to be super easy, right? There are things you need to learn, of course, but these are just the two sides of doing machine learning: concepts and what implementation. So what we did yesterday was concepts-based implementation. So now the steps I highlighted the steps in building a logistic regression model or any kind of model it is, right? So we're using logistic regression model as an example, but this applies to any machine learning model it is that you want to use, whether you're using linear regression or whether you're using decision trees, whether you're using random forest, whether you're using XGBoost, whether you're using whatever model you're using, it follows this same step we have here. All right. And this is when you are strictly doing machine learning. You don't have anything to do with EDA, you don't have anything to do with all those preliminary steps that we've looked at previously, right? But in reality, our data set is not always ready for machine learning. So that's why we go through those steps of cleaning our data and making sure that it is in the appropriate format. We also do EDA to understand and all of that. But today we're not going to do EDA because our focus here is building a machine learning model. All right. So we've done the EDA part, and you should understand how to do that. So the steps in building a logistic regression model. The first one here is loading data sets. Of course, you can't do machine learning without data. So what you have to do first is to load your data sets. All right. Whether you got your data set yourself, or you download it from the internet, or your company gave it to you, whichever, or your data engineering team created a pipeline for you to get your data set, whichever method you want to use, it's fine. But the main thing is that you get your data set. All right. Today we're going to be looking at how we can access some data sets from Sklearn. Sklearn provides us with data sets that we can use to learn. All right. It provides us with data sets that we can actually use to learn. So we're going to look at that also. So after looking at the data set, the next thing is to split the data set. All right. The next thing is to split the data set. After splitting, then you train the model. All right. After training, then you evaluate the model. So this step I just highlighted now, yeah, exactly the same thing for other machine learning algorithms. So I need you to understand this because I will not be repeating it again. So just have this at the back of your mind whenever we are trying to build any machine learning model. Even the assignment of giving as well, you just that these are the steps to follow. All right. So now we're going to go through these steps one after the other. So the first step here is loading the data set. Now we don't need to give ourselves headache because Sklearn, scikit-learn, Sklearn are used interchangeably, so don't get confused at the same thing. But I prefer to use Sklearn. Sklearn has inbuilt data sets. All right, and I'll show you how you can access that. You don't need to study, you don't need to do any cleaning, you don't need to do any pre-processing. Just go straight to using it to build your machine learning model, right? So today we're going to be looking at the data set, which is the breast cancer data set. All right. So this data set is a binary classification data set. So we're going to be using it to see how we can build a model using logistic regression. All right. So let's jump on that. Loading our data set from Sklearn. All right. Don't make any bold. Let's have it here. All right. So now, how do we get data set from Sklearn? I told you that in Sklearn, what you import is based on the task you are performing, right? You import specific things, you import things specifically. So in this case, we actually want to use the data set from Sklearn. So we have to import the breast cancer data set, all right? So what I'm going to do here, I'm just going to say from Sklearn dot data sets. Before I do that, let me just say from Sklearn import data sets. Okay, this is not done. So from Sklearn import the data sets, so we're going to now come here and check out the contents in the data sets. So now we've imported the data set, right? So the data set is a module that contains the data sets that are available in Sklearn. So we use a print dir. So if you scroll down, you're going to see everything here. All of them are actually data sets. So we can see if we look for the load breast cancer data set, you can see it here. Load breast cancer. All right, you can see this one, load diabetes. You can see this one, load sample image. You can see a lot of the data sets here. All right, so you can see fetch California housing, fetch this, fetch that. So these are the data sets that are readily available in Sklearn. So you don't need to go and start searching for the data set if you're trying to learn how to use build models in Sklearn. So that's actually very good of them. So today we're going to be using the load breast cancer data set, right? So these are all the data sets that are available in Sklearn. So to import that particular data set, I'll just come here and see from sklearn.dataset import load breast cancer, all right. So I run this. If I come here to get access the data, you have to do some things. Alright, the data set, because I come here and say load breast cancer, you see it gave me this output that is a function, all right? So there are things that you need to do to actually access the data in this particular data set. If I check the type, print type, what is the object type? Because it's an object, right? So what type of object is it? Is it a data frame or what? You can see that it's a function, all right? So for the fact that it's a function, you have to actually put your parentheses there. So I'll come here and say load breast cancer, and I'll put my parentheses, and you see that it gave me an output. All right. So there are a lot of things happening here. You don't even understand the pattern or the what is happening, the nature of the data set. So we're going to actually break it down and see how we can access the data here. Okay. So now this is the data. This is actually the data set. And the data set is actually divided into two parts. It's divided into the independent variables, which is the X variable, and it's usually called data. So the data set returns a dictionary, actually. It returns a dictionary so that we have one key here, data. The second key is target. The third key here is what? Frame. The fourth key is target names. Fifth key, description of data set. All right. And we have feature names as well. All right. Which is the sixth key. We have file name, and we have, so it returns a dictionary. If I come here and say, let me access the keys. Let me see if I can access the keys. You can see that it gave me the keys now. You can see I have all these keys here, right? Data, target, module. So I'm just going to leave that and start accessing them one by one. So what I'll do, I'm going to assign the output of this function to a variable. I'll call it data set. All right. I'll run that, and I'll come here and say data set dot keys. Give me the keys, right? You can now come here and say data set, and you know how to access, you know how to use a dictionary, right? So you can see the importance of the foundations we looked at. So this is a dictionary, and you know how to access a key in a dictionary. Okay, let me just even access our knowledge, you know, if we still remember. So let's say we want to access the feature names from this particular dictionary. What syntax are we going to use? What syntax will we use, right, for accessing the feature names from this data set? What is the exact syntax? Okay, I'm getting two different answers here. I'm getting data set 5 and then data set feature names. Okay, I think we are confusing list for dictionary. So let's see. We come and say data set 5. we're going to get an error. Why? Because we are not trying to index. Remember the characteristics of a dictionary. It doesn't have indexing like lists and other data types. All right. How we access the data is via the keys, and we use the key name. All right. We use the key name in the brackets, not a number. The number is usually an index when you want to access items from a list or a tuple, all right, and all those other data types. But a dictionary is different. It's just like a data frame, the same thing as a data frame, all right? So to access feature name, you just come here and say feature names, then you put it here, all right? So those people that gave the syntax, you're correct. Then you run it, you see the feature name. So these are all the features we have in our dictionary. All right. So you can see there are actually a lot of features here. All right. There are actually a lot of features. So that's how we can access any of the uh, any of these keys in this particular data set. So depending on the data set you're using, this is the same method you use. So this is specific to Sklearn data set, all right? Sklearn data set. So now, what you do next when you load your data set is to actually get the independent variables. And now the independent variables under the data is getting the independent variables. So I would assign them to X, right? And the data set data. So data are the data contains the values for the independent variables. So I'm going to run that, right? So for y is the word dependent variable. So y is usually on the target key. So we come and say target, and then close our bracket, all right? So you can see this is our dependent and independent variables, all right? So hope everyone is still following. All right, that's great. I just want to be sure that we are following up to this point. So these are the this is the x the independent variable, and this is the y dependent variable. So if we check out the content, if I come and say x, you see that it's giving me an array. All right. So these are the features, and it doesn't make sense, right? You are not actually understanding what feature are listed here. So, but you don't have to disturb yourself about that, because everything has been organized for you to train immediately with your model or with your algorithm. But to understand your data, you can actually convert it to a pandas data frame. All right. So to do that, we're going to use pandas. So quickly, you see how the Sklearn data set gave us an array, and that shows you how tightly integrated Sklearn is with NumPy. So let's see how we can convert this data into pandas data frame. All right. So I can come and say xdf and say pd dot data frame. Because of time, I wanted to ask us to drop how you can use pandas data frame to convert this data into a data frame. But I'm just going to do that myself. So what you have here first is your data. All right, you have your data. So come here and say data equal to what? X, and then your columns. The columns are the features. All right, so the columns are actually, come here and say features is equals to data sets, and I'll say feature names. All right, so I'm going to run that. I'll come and say features. Okay. So I've now imported, I need to import pandas, all right? Import pandas as what? PD. All right, so let's come back here. So I've converted this to data frame. So if I come and say X, df, you can see I have this, all right? So all the independent variables have been converted to data frame, and they're now presented in a very neat fashion. So you can now do all those exploratory data analysis that you know. But for the sake of this class, we'll be going straight into the machine learning aspect, all right? You can add the target variable, which is the feature, the y. Just come and say xdf and say target. Come on here and say y. All right, so if I come and say xdf, you see that target is already here, 0000001. So this is basically how you can convert your Sklearn data set into a pandas data frame for easier understanding, right? So now, after the loading, this is the loading aspect. This is the step one where you load your data set. All right. So the next step here is what? To split the data set. All right. The next step here is to split the data set. So we're going to talk about some few things in this particular step. So why do we split the data set? Now we split our data set into training and testing sets. So in machine learning, before you train a machine learning model, you have to split that data. All right. You get the data, you split it. You split it into two sets. You split it into the training data set, and the second part will be the test data set. Why? Now, what you're trying to achieve in machine learning is to train your model, a model on a particular data set, and then test it on a different data, on another data set similar to the one you trained it, right? But the one you are testing it on is a set of data, or is a data set that it has not been trained on. So basically, it has not seen it. All right. So now you have to make sure that you have a separate data set for testing. So the testing is almost the same thing, or is the same thing as evaluation. So all the evaluation that we've been talking about, both in classification algorithms and in linear regression, they are all done using your test data set. So you want to make sure that your model is performing well. All right. So the training data set is for training, while the test data set is for testing the performance of your model. Because if you test the performance of your model on the training data set, it's going to give you a very good performance because it has seen that same data. All right, it has seen that same data. It's just like you want to set an exam, right, for some students, and then you now, instead of giving them Okay, you now give them the same question that you are going to set. Let's say the exam is tomorrow and they are trying to revise, and you now give them the exam question before the exam date, and they went through the exam question and they memorized everything. On the exam day, they are going to get a perfect score, all right, because they've already been trained on the exact same questions. All right, they've been exposed. So that is the same thing that we're trying to avoid here. We don't want to train our model on a particular data set and use that same data set again to test it. Because if we are testing it, it's going to be like, oh, I've seen this thing before now. It was what I was trained on. So it's going to give you a very good it's going to perform very well basically. So what we want to try to do is to give it a different data set that it has not been trained on, but similar to the one that it was trained on. So you use it to assess how your model will perform on unseen data sets. All right. Is going to give you an idea on how your model will perform in the real world. Because when you are trying to build, let's say, a breast cancer detector, all right, that will be able to detect breast cancer and all of that, you trained the model with millions of images, right? And then when you're now getting, or when you want to use it in the real world, the image would be that would be used in prediction, or the image that you're going to be giving that model is an image that it has not seen before. It's like a new patient just came in, and that you want to use that patient, you want to use the model to predict whether that patient has breast tumor or not. So that patient is a new and is providing an entirely new data. It has not been exposed to the model before. So once you bring that particular image of the new patient and give it to your model, the model has not seen it before. Only the thing it has seen are the ones it was trained on. So it should be able to make a very good prediction on data that it has not seen. That is what we are trying to replicate here. We are trying to split our data set into training data set and test. The train will be used to train it. The test will now be used to test it on its ability to make predictions on unseen data sets. That is how you know if your model is actually doing very well. All right. So that is the step 2 here in machine learning. Generally, not just logistic regression, we split it and we actually use a particular function in splitting. All right. So we're going to import that too, and I'm going to show you how to split our data set. So let's proceed to how we do that. So step 2. Splitting our data set into train and test sets. All right. So we use a different function for this. So we import it specifically. Can you now see the trend now? We are importing the specific functions and specific classes that we are using in Sklearn. So we don't import Sklearn generally. We import the specific packages or the specific function we want to use. So before you start, you will have to import everything at the start. So the reason why I'm doing this separately is just for you to understand. But you don't do it like this. You import everything at the start, and then you proceed. Anyone that you forgot to import as you are going on with your work, you then go back and import it and run the cell again. So that is exactly how you work in Sklearn. So to import the function for splitting, you just have to come and say from sklearn.model selection. So model selection is the particular module that contains the function for splitting. You now say import train test split. All right. So just to confirm, yes, train test. So this is the function. All right. I will just run that. You can do your shift and tab. It will show you exactly what it is and explain all of that. So don't forget your shift and tab, right? So you can also always do it on any function or objects that you don't know anything about. So to use it, you have to know your X. You have already gotten your independent variable here, which is X, and you've gotten your dependent variable, which is Y. So these are the two things you need, right? These are the two things you need here. So to split it, you would come here and say train test split. If I check it, you see that it takes arrays. All right, so the arrays would be your independent variables and your dependent variables, and then you have to specify the test size. So I'm going to show you or tell you what that means. So the first thing you just put your independent variable X, your features, and then put Y. All right, so these are the things you want to split. You want to split these two variables, or these two set of variables. So you come here, next thing to indicate is your test size. So your test size is the proportion of your data set that will be allocated to your test data set. So let's say you have 100 observations. The size of your data set is 100, and you want to make 30 out of the 100 observations your test data set. So you would specify it here by saying 0.3. All right. So it's like a proportion stuff. So anything you put here is going to be the number of observation or records that will be allocated to your test data set. Okay, if you put 0.2, 20% of your data set will be allocated to your test. So the rule of thumb is to make sure that you are giving more data to your train data set and less data to your test, because you want to ensure that your model can see enough data during training so that it understands patterns. All right, so it understands patterns well enough to be able to generalize to unseen data. So the test data set is always small, or should be smaller than your trained data set. All right, it should always be smaller. So the advised range is usually 30% of your data set or 20% of your data set. So for this, we'll be using 30%, which is 0.3. All right, and then we're going to say random states. We have random states here. So random state basically is going to help this particular code to be reproducible, because this splitting process is a very random process, right? It selects 30% of your data randomly. So once you indicate random states here, it makes that particular data set that was selected to be selected again and again and again and again. So it removes that randomness. All right, so I'll come and just give any number here. So I think I explained this already. Random states during NumPy. So these are the parameters that you would have to indicate when splitting. You indicate your X, indicate your Y, and then your test size, and then random states. So if I run this actually returns four different sets of values. All right. So you have to assign those outputs to variables, right? You have to assign the output to variables. So what we have here, we have to come and say X. We don't just say X. We don't just assign it to one single variable like this. We assign it to 4 different variables because it is returning 4 different outputs. So if you return it like this, we are going to come and see that our X, if you come and print X, you see that X is actually a list, right? X is a list. You can see the bracket that starts here. So it's a list. I think it's a shape. Okay. And X. So you can see that the length of X is what? 4. So it has 4 different arrays in the list. So in order to unpack it, we just have to assign the output to 4 variables. And the way we normally do it in machine learning is to follow this particular notation. So you come and say strain and x test, right? Because what it does is it first splits this x variable, right? So into 2, which is your train and test. So you put it x train and s test, and you come here again and say y train and what y test. All right. So this is basically how it is. Let me zoom out so you can see it. So this is the syntax for splitting your data during machine learning, during the machine learning process. So you use your train test split function, and you make sure you put all these parameters, and then unpack them to these 4 different variables. If you have just one data here, you just have to unpack it to just 2. All right, and unpack it to 2. If you have 3, you unpack it to 6. All right, so because the function splits each data into 2 parts. All right, it's split it into 2 parts. So you have to make sure that the number of arrays you have here corresponds to the number of splits that you have here. So we have 2 x and y, so that it will have to be x train and x test. So we'll run that. Okay, what's what is the problem? What is the problem? Sure. Yeah, this should be running very well. One input variable equals to 4, 4, 5, 6. Okay. I think it's because of this that we did here. I have to delete this x variable and then run it. And then run this one here. And then come here. All right, so now we've unpacked that into these 4 different variables. So you can bring them out one by one and access them. The type, they're actually arrays, so you can come and say print type. You check the type of each of the variable. You can see them here. So you see that is a numpy array. All right, so each of them are numpy arrays. So you can actually access their shape. You can come and say string dot shape. You can see that it's 398 observation with 30 features. I come and say what of x test dot shape, that is 171. So if I change this to 2, that is 20%. The shape is going to change. Let me just print it out so you see it. So, x string. So you see that it has changed now, right? From 171 to 114. Now our X train is 455 observations, while our test data set is 114. So we've successfully split our data set. We can as well check the Y train. The Y train is always Y train. Come here. So Y train and Y tests. Train. So you can see that is the same thing. The Y test has to correspond to the Y X test, and the Y train has to correspond to what the X train. All right. So you can see 114 here, 455 here. If I change it to 10%, you see that it's going to increase the X train, the train data set to 517. So you can see how the size here affect the number of observation allocated to the train and test data set. So let's just keep it at 20%. All right, so we're going to have this here. So this is the step 2. Step 3 is splitting our data set. All right, you can go on to check out the content of each of the data sets. That's fine. All right, but you've successfully splitted your data set, and that is what you're going to be using for training. So let's just go back to what we've done. So the first step we did was loading our data set from Sklearn. All right, so I showed us how we can load data set. I showed us the particular module which is called data set that has all the built-in data set in Sklearn, and you can select any one of your choice. And today we are using the load breast cancer data set, right? So it's a function, so we have to load it and assign it to a variable, and that particular variable has it in a dictionary-like format, right, with keys. All right, with keys. So you can access each of the key in the data set and also the specific data that we want and assign it to a variable. And that variable, we can now use it in our splitting as we've done here. We've splitted the X and the Y, which corresponds to the independent features and the dependent features. So we just assess the shapes of the different data that we splitted here. So this is the second step. Now this third step is the main thing, which is training our model. All right, this is where we now train our model. So in this case, we're using a linear regression model to fit our data. All right, we're using logistic regression to fit our data, and specifically training data, not just any data, our training data. Remember, that was why we split it here initially to X train and S test. So the train data set is what we're going to be using for training. We are not going to be using this X test data set for training. It to be reserved for when we want to assess the performance of our model. So how do we do that? So let's just come here. I'm going to come here and say training our model. All right. So the same thing applies here. We have to import the specific model we want to use. So in this case, we are using the logistic regression model. So we're going to have to import it. Importing the model to use. All right, so we'll use that by saying from sklearn dot model linear models, if I'm right. The linear models with an S, okay, no S. Import logistic regression. So there's something that I just did now. All these things are just things that can help you code faster. So if you are typing something or trying to write a function that is in Python, before you complete it, if you don't know the complete function, you've forgotten the spelling or something, as you are writing it, you can just press tab in your keyboard while in Jupyter Notebook, and it will give you the options that are available. So in this case, you can import logistic regression CV or logistic regression from linear model. All right. If I say linear and I press tab, you can see that it's giving me the option of linear regression. So I could just press enter and it will auto complete it for me. So that is actually another shortcut in Jupyter Notebooks. So this one is just by the way. It will actually help you a lot. So in this case, I'm importing logistic regression. Just press enter and then run it. Okay. So now this is what we're going to be using for our model training. If you use Shift and Tab, you can see the documentation for linear logistic regression. I don't know why I keep saying linear regression. And you can see the parameters that it takes in. All right, the different parameters. Okay, so let's see how we can fit our model to our data. So fitting our model to the data, to the train data. So this is basically training our model. All right. So fitting our model is the same thing as training our model. Fitting our model to the training data is the same thing as training our model, right? So how do we do this? What do we do? Now we've imported logistic regression. This is a class, all right, and I told you the notation of a class is usually a camel case, all right. Each word begins with a capital letter. So that is what you used to know a class. This one that we have here, this train test split, this is a function, right? This is a function. So, but this class is what we'll be using here. So to use logistic regression, you have to create an object of the class. All right, you have to create an object. How do you create the object? By assigning the class to a variable. So we can just name any variable here. We'll say log model. I'll come and say logistic regression. All right, open and close bracket. So you can either just leave it like this and not put anything inside there. It will still work fine. Or you can actually put some parameters there and change it. But let's just start with this. Let's just start with the simple approach. So we assign this particular logistic regression model and to a variable. So what we did here is just creating a logistic regression object. So this object is what we're going to be using in train to fit our data. All right. So what next? What next? So the next thing here is actually to now fit the model to our train data or to train our model. So I come here and say training the model. So how do we do that? By saying log model, that is the object we've created here, and we'll say dot fit. So this dot fit is an attribute, is a method that is used to actually train our data. You can see it here. If you press Shift Tab, what does it do? It fits the model according to the given training data. All right, it fits the model according to the given training data. What does it take as parameter? It takes your X and your Y, which should be your training data set. So I'll come here and say fit and say X train and what Y train. So these are the two things that you need. We don't say X and Y. You don't come and say X and what Y. If you do this, you're actually fitting the model to your entire data set, which we don't want. All right. We split our data for a reason. I'll come here and say X train and what Y train, and then run it. So it's all these things are just warning, right? They're just warnings. So you get this output here, logistic regression, that you've actually completed the training process. So it's actually very, very fast, very fast. So that is actually how we train a model using logistic regression algorithm. Hope everyone is still following and you can all still hear me clearly and see my screen before I proceed. All right, great. So these are warnings. What we have here, they're actually warnings telling us that, just giving us some information that we should actually pay attention to, but you can actually ignore them. All right, so you can come and just say, ignoring, this is out of the scope of machine learning. This is just a Python stuff. You can come and say import warnings and say warnings dot filter warnings and say ignore. I think it should actually be this one. Let me check to be sure. Okay, great. So if you don't see warning, you can use this code here, filter warning. So you just ignore, so it doesn't show you warnings again. So you can see once we fit our model, we get this logistic, this output here. All right, so this is the output we get. We've actually trained our model. We've actually fitted our model to our data. Now we can now use it. We can now test it. All right. We can now test it using what? Our test data set. So we've looked at the first three steps, which is loading the data set, followed by splitting our data set, followed by training the model, and then we're going to look at evaluating our model. So this is where you're going to spend most of your time during machine learning. Right? This is where you're going to spend most of your time during machine learning. So now let's quickly come here and say evaluating. Evaluating our model performance. So everything we talked about yesterday, we're going to be showing how we'll implement them here. All those classification metrics we talked about, we're going to be looking at them one after the other. All right. So I'm seeing some questions here. And Rita, you said you are lost. What parts exactly are you lost? Because if it's everything, then you have to just wait for the recording. Understand that understand that this can be overwhelming at first, right? Which is very normal. So don't stress yourself so much. Once you get the recording, you take your time and go over it again. But have specific questions, don't fail to ask at the end of the class, right? So um I understand your light at the moment. Happiness. I actually didn't see the message. I didn't ignore it. I didn't see the message. So I'm actually just looking at it now. Okay, real one. You don't know how to determine the independent variable. I suppose I wasn't told. Like once you're given a business problem, you would already know, you should know what you're trying to predict. So what you're trying to predict is your dependent variable. That is it. It's not going to be an issue at all. So what you're trying to predict is always your dependent variable. Right? So understanding the business problem would give you an idea of what the dependent variable should be. All right. So that's for that. So let's just proceed with the evaluation. If you have any question, just note them. Once we are done, you can ask. Now we looked at different methods of evaluation. All right. Yesterday, the first one we're going to look at now is accuracy. Accuracy. Okay, how can we use accuracy to evaluate our model? So we have to import accuracy. Remember what I told you? Sklearn requires you to import the specific functions you'll be using. So you have to import accuracy, and we can see import it by using from sklearn.metrics, right? Everything, all the evaluation metrics, they are under this metrics module here. So I'm going to come here and say importing the metrics for evaluation. So I'll come and say from sklearn.metrics import. So if you have a lot of metrics to import, so it's usually advised that you import everything at once. All right. It's usually advised that you import everything at once. So I'll come here and say we have accuracy score. You can see now this particular tab is helping me. I can come here and say classification confusion matrix. So I press tab, give me. So you can see how this is very useful. I can come here and say what which other precision I'll just say preci, and it will give me different, say precision, recall call, precision. So this is what I want, precision score. Press enter. Come and say recall, press recall. I have ROC, AUC, and then you run that. So these are the metrics we're going to be working with for now. So just press tab. So you can, if you're importing a lot of things from one particular model, you can use this particular function. All right. So just put everything in brackets. But if you don't put everything in brackets, it's still the same thing. The code will run very fine. Just to make your code look cleaner. All right. So we've imported the metrics for evaluation. So the first metric we're using is accuracy. Determining the accuracy of our model. So how do we do that? We come here and say, first, we have to get the predictions. All right. We have to get the predictions first. Okay. The targets for this breast cancer model is to know if the person has breast cancer or not. You can read that in the description here. So if we come here, if you want to understand it, you can come here and just say data set, and you use this description key here, and I think it should give you the description. So I'll use print so to print it out very nicely for me and remove all those stuff. So you can see it here. This is the description of the data set. This is the heading: breast cancer Wisconsin diagnostic data set. Data set characteristics: number of instance 569, number of attributes 30 numeric, predictive attributes and the class, attribute information. So they gave the information of all the attributes here and all of that. So the class, okay, the class actually 0 and 1 is malignant and benign, which is the same thing as present and not. So malignant means that it is cancerous, all right. Benign means it's not cancerous, all right. So, and then they give summary statistics and all of that. So the dates of publication of the data set and a lot of other useful information. So you can use the describe key to understand the data set you are working with. So any data set you are loading, you can use this particular key to understand it better. All right. So thank you for asking that question. Who asked the question again? All right, Kuma, thank you for asking the question. All right, so let's just proceed. So we've imported all the metrics we are going to be using for our evaluation. So the first one is the accuracy. But before we use accuracy, we have to get the predictions of our model. To get predictions of our, you've trained your model already, so you can now use your model to make predictions. So how do we do that? We'll come and say log reg, because this is our model, right? If I run this, is it log? What do we? Okay, log model. We use log model. All right, you can see this is our model, right? It has another attribute, but this attribute only functions after you've trained it. So the method only functions after, which is called predict. All right, predict. So this predict method will be used to make predictions. And what we are going to be predicting is we're going to be using the X test data set for predictions, all right? Because that's what we want to use to evaluate our model. We want to use something that the model was not trained on to evaluate its performance. So I'll come here and say X test and then run it. So you can see these are the predictions that the model made, all right? So if I come here and say Y train, I'm going to print this so it will remain visible. I just want you to see something. So you can see now, these are the, X train rather. S, sorry, Y test, sorry. So these are the this is the prediction, all right, and these are the actual values. Right, this is the prediction and this is the actual value. So what the accuracy score does is to compare each of the prediction with the actual value and compute the accuracy for each of them, right? It takes into account both the positive class and the negative class. So when we use precision takes into account, it looks at only the prediction, all right, and looks at the positive predictions and see how many positive predictions were actually accurate over the total number of positive predictions. So all those things we explained yesterday will be happening with this output that we're having here. So it will be computed with this output. So let's look at how we can predict the accuracy score or get the accuracy score. So we use log model predict to have to assign that to a variable and name it y predict. All right. So to use accuracy score, you come and call it accuracy score. And you put it takes into parameters or two arguments, which is y test, which is the actual value, and y predict, which is the predicted value. All right. If you come here and you put tab, you see that it's the parameter y true and what y predict. So I'll come here and run it. What is my accuracy? My accuracy is what 0.9298. You can say that the accuracy is actually high, meaning that the model is performing quite well. All right, so the accuracy is 0.929, but we're not going to stop there. We're going to quickly check something. Now, let's see if there's class imbalance in our data set. So we will know if we can rely on this accuracy metric. So come here and check the Y. We'll check the Y, the main Y, or not the splitted Y. So I'll come and say, this is our Y here, right? So what? Okay, let's use the X data frame that we created. All right, we'll come and say target dot value count. So you can see the count of the positive and the negative class. So the malignant, which is the positive class, has 357 observations, while the second one have 212. So is this data, this variable, is it balanced or imbalanced? I want to get your response. I want to get your what you think. Is it a balanced data set or an imbalanced data set based on this? Okay. Okay, I can see that there are a lot of different opinions on this, which is okay. But to me, looking at this is actually a fairly balanced data set. Is not bad if you use accuracy as a metric to assess your model. So it is actually not so, the difference is not so much that you call it an imbalanced data set. All right. So as I said before, you should not expect it to be very close to each other or the same number before you call it a balanced data set. But you should know that the difference should not be so much. All right. The difference should not be so drastic. Let's assume if the negative class here is 150 something, then and this one is 400 and something, then you can know that it's actually an imbalanced data set. So you just have to, there's not a strict rule that tells you the range from which you classify it as balanced or not, but you look at it and just use your judgment to determine whether it is a balanced data set or not. But the range should not be so much, right? So yeah, that's just it. So I believe you are getting to understand what we've been talking about yesterday. So this is the accuracy. So the accuracy here is what 92. So I'm just going to come here and say accuracy and say print the accuracy of my model is what? All right, so I'll just come here and say round. I think there's a way you can actually make it to decimal place without think okay. Anyways, I would try to remember it, but I'm just trying to round the values because it's too long to two decimal place. So I'll just use the round and come and say 2. So we can see the accuracy of our model is what? 0.93. All right, 0.93. So let's move on to other metrics. We're going to use the precision and recall. All right, getting the precision and recall of the model. So we've imported precision, right? So I can come and say precision, the same arguments. It takes y test and what? Y pred. If I run that, precision is not okay. Precision score, not precision. So precision score. That's why it's good to use this tab just to give you the stuff immediately. So you can see the precision score is almost the same thing to 0.92. Let me just copy this here. Copy this and paste here. Right? And say precision equal to this and come and say precision 2. So the precision of our model is what? Let me make it 3 decimal place. 3 decimal place. So that's for precision, and then we're going to do for recall as well. So our precision is quite high. So come and say recall. Just say tab, enter. And then, so I believe by now most of you will be very happy about this tab stuff just introduced because it will make your coding to be much more easier. So you can see our recall is actually higher than our precision. Our recall is 0.955, precision is 0.9. So this is basically telling you that your model is very, very good. Like it is very good. All right. So this is not what you should be expecting because this data set is a built-in data set from Sklearn. So they've made it in a way that it gives you a very good performance. All right. So that is how you get your accuracy, you get your precision and recall. So based on the business problem or based on the task you're performing, you now start to interpret this precision to know exactly how the model is performing. All right. So there are some other metrics that are very important. Now we're going to look at confusion matrix. All right. So we imported confusion matrix, and then you use the same. You can also do the tab for the variables. All right, so you can come here and say pred. Okay, it should be pred. This one should be test. All right. So confusion matrix will give you something like this. So remember what I said, that the confusion matrix will give you what? The true positive, true negative, false positive, and what? False negative. So the diagonal side is what? True positive and true negative. Let's go back to yesterday's material to see what it is. So you can see the confusion matrix here. True positive and true negative, they are on the diagonal side. All right, false negative and false positive, they are on the other diagonal side. Now, you should make sure that what you should be expecting is the value on this diagonal side is higher than the value on this diagonal side. So you're trying to maximize the value from this right hand side to this, from this point to this point. So if you are seeing this particular diagonal, let me zoom in. If you are seeing this 5 and 3 to be very high, that means your model is bad. All right. But if you see this 43 and 63 to be higher, then your model is actually good. So you want to make sure that what you want to see is the value on this diagonal side to be high, like very, very high, much more higher than the ones on this part, because this is what will determine your precision and your recall. So you can see that it is the false negative and false positive, they are low, and true negative and true positive are actually high, making your precision and your recall to be high. All right. So all these things, they are actually working together. So you can make your confusion matrix to be, let me just say C matrix. All right. I can actually use Seaborn. I'll come here and say Seaborn import Seaborn as what? SNS. I can use heat map, all right, to just visualize my confusion matrix. I'll say C matrix, enter. All right. So you can see that it has given us this particular thing. So I can come and say and not equal to true. So you can see it has annotated it for us. So just to make sure that the thing is visible, I can just reduce the figure and say fix size equal to, let's say, 5 by 3. All right, so I have to import matplotlib dot pyplot as plt. So it's even still bigger. I think it's because I zoomed in. Let's see, 3, 2. All right, so you can see it here. Visualizing it with your this thing makes it even better. So the diagonal side, you can see the false positive and false negative, and true positive and true negatives. All right, so that is it for confusion matrix. All right, so let's just go to the next one. We have what we call classification report. I don't think I told us this in the class we had yesterday. Classification report. Classification report is like a summary of everything. It's like you want to see everything at a glance. All right. So how we will do that is by, I think we imported it, right? Let me be sure we imported classification. Okay, we didn't import it though. So we'll have to come here and say classification report. All right. So I'll come here and say classification report, and we say y test and what y read. Run that. Let me say C report because I want to just print it out. So almost everything you do, put them in a variable. So it will be easy for you. I'll print out the variable C report. So you can see that everything now is in one place. Precision or recall or F1 score. You can see F1 score is even here, right? Accuracy and a lot of other things. So this is like a summary, a snapshot of all the metrics in your almost everything in your classification model. So based on this, you see that your model is actually okay. It's not bad. You can proceed to using it in real life situation or real life scenario. All right. You can save your model and then push it to production, give it to your backend engineer and your front-end engineer to incorporate it into the application that the user will be interacting with. All right. So this is just machine learning for you. All right. This is the steps we followed now. We followed through is a typical step of creating a machine learning model. All right. So the other things we'll be doing subsequently will be building on this foundation that we've set today. All right. So we are not done yet. I think we have one more model. We have one more metric, which is ROC. We've not looked at ROC curve. So if you look at the material described every evaluation metric, explaining everything here. We're not going to go through all of that, but once the material gets to you, just make sure that you look at it. All right. So these are the steps we used. We loaded the breast cancer data set. We split the data set into training and test sets. We trained the logistic regression model on the training set. We evaluated the model using accuracy, confusion matrix, and classification reports. Now, I think we have to look at the ROC curve because it's very, very important. So, okay, we're going to look at that in subsequent classes. All right, but that one is there are a lot. There's some steps we have to do in order to get that get it to make sense. So now we've looked at binary model. How can we now train a multinomial logistic regression model? It is the same step. The only difference is the data set and a particular parameter in our logistic regression model. So now, if we have a data set, in this case, we're going to use a different data set, which is what? Load digits. We'll go to our data set where we imported our data set and load digits. Just come here and say, copy this and say load digits, run it. I'll just come here and change this to what? Digit. All right. So you run that, run this. You see that it gives us the description of the digit. So this is an optical recognition of hand-reading digit data set. So number of instances 1,797, number of attributes 64, attribute information, all of these that you can see here. So this is a data set that actually classify handwritten digits into from between 0 and 9. All right. So you have 10 categories actually. So this is a multinomial logistic regression problem. It is more than 2 categories. These are all the information you need to know about the data set. So if I come here and create the data frame and just use the same code as before, you can see we have a different data frame like all of this. We have see the targets here. We have 0, 1, 2, 3, I think till 9. So now we will do the same thing as we did before. We can split it, give us a different split. All right. The same thing, we use logistic regression model, but now when we come to the model, there's a parameter we need to adjust to make it adjust to multinomial regression. So the parameter is what? Multi-class. All right. So if you scroll down to multi-class, you will see, scroll down. Let's see. You can see multi-class here. We have 3 different things. We have auto, we have OVR, and we have multinomial. So this is what we are paying attention to. We'll set it to multinomial. Copy this, come here and say multi-class and say multinomial. So this basically tells the regression, this model that, okay, this data set is a multinomial data set. It has more than 2 classes. So if I run that, okay, let me close this string. If I run that, it should give us fit our model to the data set appropriately. And then we can now use this, can now come here and access our model. Let's see. Come here. You can see the accuracy of the model is 0.98, very high. You can see when we use the values count, it gave us the value count of each of the categories. So it's actually a very balanced data set. I'll get the position and recall. Okay. The thing is that you can't actually use. I just remember you can't actually use precision um, um, and recall for this because of the nature of the data set, right? You don't have positive and negative um, classes here, so they are multinomial data set. They are different classes. So you the best bet is using your accuracy. You can also use your confusion matrix to actually look at the rightly predicted values. So the ones on the diagonal aspect are the ones that are correctly predicted. All right, correctly predicted. Unless you want to specify, you want to look at the precision and recall of each category. All right. If not, you would have to just stick with the accuracy and then come here, the classification report. It will show you. Okay, you see that the classification report actually give you the precision for each of the category, right? You can't use it directly here, right? But once you use classification report, it will calculate it. It will take each of the category as a binary problem and calculate the precision of that category. Come to the second category, take it as a binary and use that one as positive, and so it does the same thing for all the categories here. Calculate the precision and recall, so you can look at each category and their precision and recall and F1 score and all of this. So there are a lot of information to glean from this. So the difference between the binomial and multinomial is just this thing you put here, multi-class parameter, specifying it to be multinomial, no, multinomial, all right? So, but by default, we have auto. And what auto does is that it actually adapts to binary or multinomial. So if we leave it at that, it will still run. The reason why I wanted to show you this is so that you understand what is happening. If you not put anything here, if you don't put anything here, it will still run, all right? Because logistic regression, the people that built it, they made it to adapt to the data, depending on the number of classes, to still adapt. But I just needed to use this as an example so you understand exactly what is happening. All right, so that is it for logistic regression. We won't go in, we don't, there's no need to go into details on interpreting all this. So you should know that anything on the outside of this diagonal, they are the wrongly predicted values. So in this case, we have just 1, 2, 3, 4, 5, just 5 of them, all right, which is very, very good because that is what you want. Okay, 6, that is what you want. You want your model to predict as you want your model to predict your to make wrong predictions as less as possible, to minimize wrong predictions, right? So that's what you want. So, and that's what you're getting here. Your model is very good. So these are the things that you would use in assessing your logistic regression model. So those of us that were in classes there, I think this would make very much sense to you. And for those that were not in class, I urge you to go. I will upload the video today, this night, and as I will upload this video as well. So you go over these videos and you gain better understanding on building a machine learning model. So we've talked about a lot of things today, like a lot of things, and it might be overwhelming. All right, it might be overwhelming, but you will definitely get used to it. All right, you get used to it. So your assignment will help you as well to practice it and to get very comfortable using Sklearn. So you asked what I've said this several times that we are not looking at ordinal. Ordinal is not implemented in Sklearn. All right, you use a different library which is called Start Model. If we have extra time, like at the end of the program, we can look at it. But that is not going to be. We are not going to be focusing on that. So these are the um two types of logistic regression we're going to be looking at. All right. And this is just one algorithm. There are other algorithms that perform the same task on classification data sets. So we have a lot to learn. We have a lot to do. Okay. So just make sure you understand what we've done today, and practice it. So that is going to be the end for this class. Just take your time and go over what we've done today. I'm going to be drawing the curtain close here and give you room for questions. So if you have questions, please indicate by raising your hand. All right, Kuma, can go ahead and ask your question.
Okay, thank you, sir. Good evening, sir.
Yeah, good evening, sir.
Uh, and thank you very much for this today's lesson. It has been really a lot because I missed the one of yesterday, so it has been somehow overwhelming. But I'll still go over the video again after you have uploaded it. But for today, I just want to commend you for everything and the quality of the last video that you dropped on the 23rd. Because I was the one that complained of the videos that you've been dropping lately on YouTube. Because mostly it's always in the low this picture quality, so it's always very difficult to visualize it on this thing on the PC. But the last one was had the standard quality, so I just want to commend you on that and just plead that subsequent videos too, you should try to make the videos to be at a higher distance quality for easy viewing. So that is just it.
All
So thank
right.
you, sir.
Yeah, thank you very much for that. Everything is we've taken note of all these input and suggestions. Um, you all are the one that make this program um what it is. All right. So whatever it is that you feel would improve this program, definitely listen to it. So yeah, thank you very much for that, Kuma.
Okay, thank you, sir.
So is there any other question or any other thing before we call it a day? Any other question? Okay. So the thing is that um we okay. So another question. All right, Ozioma, go ahead and ask a question. Unmute yourself and ask the
Thank you
question.
so much. I already dropped the question on the live class. I was asking, I noticed something after the prediction. Instead of going through the prescription record, is it possible to go straight to the classification report since the classification report has a way of presenting almost what prescription has to offer and the record has to offer?
Yeah, you definitely because it's the same thing. The reason why I'm going over all of this step by step because you all are just starting to learn machine learning. So I need to take you through all the steps, all right? So that you, even
Okay.
if you don't use them, you know them. You know that there's an alternative of doing this. But when you are doing your work, you can just um get the classification report. But there's some times that you might want to maybe get specifically the precision score and you want to like maybe print it out to like format the string to maybe depending on the question you are asked, maybe what is the precision score, and you get the precision score and you use your string formatting to embed the variable and all of that. So there are some instances where getting the using that particular function would be helpful, right? So it just depends on you. So the main thing is to understand how to use all of this and how to interpret them as well. All right. So one thing that Python does is to create redundancy. So there are different ways of getting the same result, which is very good. All right. So yeah, that's just it for that.
All right. Thank you so much. I appreciate it.
Yeah, you're welcome. Okay. So is there any other question? Is there any other question? All right, marvelous. Marvelous, please go ahead and ask your question. You can unmute yourself.
Good evening, sir. Good evening, everyone. Okay, so my question goes towards
Your
aside
voice,
the
your voice is quite low.
no.
Yeah, I can hear you now.
Okay, so aside the built-in like data set on the scikit-learn, can you like load your own data set and still run this from like scratch? Like, is it possible?
Yeah, you can do the same thing, but when you once you upload your data set, you are doing it differently. You are now using pandas to upload it. So it should not be the same way you handle the data set here that you handle the data set when you upload your own data set. Do you understand? So this is a Sklearn data set. So that is why we have to go through those steps of extracting the relevant data for training. Right? When you get your pandas data set, which you're going to get, you are going to have to take a different approach. So you have to get the X variables and then the Y variable. So you already know how to work with pandas, so that shouldn't be an issue. So the other steps from splitting and all of that, they are just the same thing. But the data set itself, the loading data set is different when you want to load your own data set.
All right, sir. Thank you.
Uh, all right, Adibayo, your hand is up. You can unmute yourself, Adibayo, please, and ask your question.
Yeah, good evening, sir. Hello, good evening, sir.
Yeah, good evening. Good evening, everyone.
Okay, please, I thank you for today's class. It was
Yeah,
very precise and I enjoyed it. I don't know if you can help us with like a video that we can watch for deployment so that we'll be able to use Streamlit and Flask as you said in the last class. Because I believe that just getting the model score and all those things without deploying it may look somehow to our employer. So I don't know if you can help us with a video on Streamlit or Flash that we can watch and be able to do that. So,
all right, no problem. No problem. Taking note of that. In case we have maybe extra time, if we have extra time after this, we might look at deployment, but we'll still look at how we can save our model and send the model as a file. Right? Once you train your model, you can actually save it and maybe send it to somebody else. That person can load it on their system and also use it to make predictions. So that is like basic way of using your model. But the deployment aspect, the only difference is just exposing it to an app, right? Making it accessible in an application, which takes a lot of steps. But for the case of presentation, Streamlit is a library that kind of makes the process very easy. All right. So I'm going to drop video materials. Please, class rep, please remind me of this if you don't see it before this week ends. So you get to also watch that or learn that too. Yeah, thank you very much, Adebayo, for that. Ojema, your hand is still up.
My hand is
Do you,
still it's not up. That's a
okay,
mistake.
okay,
Sorry, sir.
okay. All right, so I think we're going to call it a day here. Thank you very much for your time. It's not easy, right? Staying for 2 hours, like you're actually sacrificing a lot. I know most of you have things to do and other things to attend to, but determining to stay in this program up to this point is a very big win, and I really appreciate that. Just keep it up, and you will definitely not regret it. So thank you very much for your time today. I believe you've learned a lot, and you've taken a lot from this class. So as usual, just drop what you've learned. I usually go through it. I went through it yesterday's zone, and I saw that not so many people um um put out what they learned. But please let us try to do that today. So just drop what you learned from this class today in the group, and I'll be going through it and looking at them. Thank you very much once again, and have a nice day. Enjoy the rest of your week, and good night.